Hey, howdy folks. I know this video's really late, but you know what? I was hoping to get a few more people to kind of sign up for the contest, but realistically only two people actually signed up. We'll get to that at the end of the video here, and I'll tell you why. If you think you signed up, you probably didn't. I'll tell you all that at the end of the video. But we're going to start talking about pistons on a gas versus the diesel. Now, this is actually the same piston and rod combination that's actually from that 2.5. So, we're still talking about the 2.5 Pontiac 4-cylinder versus the Volkswagen 1.6. You know, just in sheer size, folks, you know, now, granted, this is a 2.5, this is a 1.6 liter. You know, we can actually start talking about efficiencies between the gas and the diesel. Now, as you can see, folks, these two are significantly larger. And one, you know, this one's significantly larger than your diesel piston for the 1.6. The thing is that even though this is significantly smaller than this 2.5, realistically for the era, horsepower per cubic inch, in many ways the diesel has it, because this is rated at 52 horsepower, where most of your 2.5s out there are rated at 88 horsepower. So realistically, folks, even though it's almost double the displacement, you are talking about only a 30 horse gain? You know, a little over a 30 horse gain between going from the 1.6 to a 2.5. So keep that in mind. That there is a significant power advantage of the diesel. Now, we'll be getting into more of the efficiency and why that is in the fuel differences videos, but it does really have to do with the fuel and the overall efficiency of the engine. You got to think about it like this. This 2.5 was probably rated at about 18% efficiency, thermal efficiency, versus this diesel at close to 30, 28, 30, you know, thermal efficiency percentage. And so there is the efficiency of it. Now, the thing is that even though this is a significantly larger piston, this is a significantly, you know, heavier piston. If you take a look at the wrist pins, the actual part that connects to the connecting rod, you'll actually notice that the one for the diesel, it may be the same. Here's a wrist pin out of one of the other pistons of the motor. It's the same size in diameter. This one actually might be slightly smaller, but you take a look at the actual weight of this wrist pin in terms of how much actual thickness is there. there's actually, in many ways, this creates a lighter rotating mass, but it doesn't provide this amount of strength as this. The thing is that realistically, in a gas engine, you're talking about static compression ratios. Realistically, in this generation of engine, not much more than 150 psi in static compression ratio testing. You know, if you had a freshly remanned 2.5 liter Pontiac 4-cylinder and a freshly remanned, you know, all the nuts and bolts done, this is pushing 150 psi static compression, you know, on a compression tester. This, the actual diesel is pushing well over double that. We are looking at closer to a 450 psi of static compression ratio. And that's where it comes into this big dish here, and this is what they call a dished piston. It's actually got a cutout in the piston to control compression ratio. Static compression ratio control is there so that you don't actually have pre-ignition, because you got to remember, in a gas motor, all of your, you know, firing, that lighting off of fuel, is done by the spark plug, and you don't have a spark plug in a diesel. Diesels are, as we know from the last video, compression ignition engines. All the glow plug, this is a glow plug for this 1.6, all this glow plug does is it heats up, and it, when fuel's sprayed onto it, it ignites and allows it to start. After starting, this shuts off, you know, versus your spark plug, which is always firing at the correct time to get these pistons to move downward. Now, piston design, especially for mechanical diesels, they have this cutout to propagate flame. Now, flame propagation in a diesel is what you need to control, because if you don't get good flame propagation, you're not burning all of your diesel fuel, and then that means it's going out the exhaust. You know those people that like to roll coal a lot, you know, black smoke shooting out their exhaust? They're either firing it way too early, they're dumping way too much fuel in, or they've got actual problems with the motors. Because realistically, in a diesel, you know, of this generation, you don't want to see black soot coming out the exhaust, because that means you are wasting fuel, okay? In a diesel, you can get darn near 100% fuel burn, upwards of 90% fuel burn. And this is where a gas motor has problems. You know, a gasoline-powered engine has problems because actually a lot of that fuel is going out the exhaust that it's getting put into it. It's the deadly thing about gasoline engines versus the diesels, is because, you know, it can be upwards of 70% of your fuel that you dump into your gas engine actually goes out the tailpipe as unburnt fuel. The thing is, why a lot of people prefer a gas engine over a diesel, especially in this era, is that the diesels do have a pinging sound, and that's due to the injectors, and we'll get into that into the next, further into the video series. But pistons for a gas engine usually will either be flat, which means that this will be flat across, there won't be this cutout, it'll be flat across, and it will actually bump up your compression ratio. Typically, compression ratios of gas engines of this era were between 7.5 to 9.5. You really didn't see a lot of motors pushing that 10-to-1 compression ratio in the 1980s. And realistically, that 7.5, that's the 454 cubic inch big blocks that are in the big 3500 trucks. That's where that low compression ratio comes from. Look it up sometime. But like we've said in the previous video, diesels run a lot higher. We're talking triple the compression ratio almost. This one was rated for 23-to-1 compression ratio. This 1.6. So for 1981, yeah. Now, as you can see, ring packages are relatively the same between the gasser and the diesel of this generation, at least in these two engines. There's other diesels of the 1980s that had a heck of a lot thicker ring pack. The one that I can think of right off the top of my head is the 6.2 Detroit that GM used. That's got a thick 3-inch ring pack, you know, where it's got 3-inch top ring, 3-inch bottom ring, and a 3mm top ring, 3mm secondary ring, and a 4mm bottom oil control ring. And I kind of find it weird, especially after looking at the 1.6 and knowing that this 1.6 is the same era and generation. And in many ways, Volkswagen used the same materials as Detroit did in the 6.2, but for some reason, Volkswagen was able to get away with a much thinner ring pack in their engines and still create an engine that does not produce excessive soot. Realistically, folks, if you ever go back in the video series and watch me fire up the Rabbit project, you don't see soot coming out the exhaust. And you know what, if you don't believe me, put it down in the comments and I'll make a special video just for you folks out there, and I'll even rev the piss out of the motor just to show you. So when it's cold, yeah, you got a lot of white smoke coming out, but that's a lot of water vapor. You get that in either engine, gas or diesel. And I've actually seen some gas engines, especially these newer modern gasser motors, where they actually produce a heck of a lot of steam out that exhaust. And that's just condensation just blowing out the exhaust, you know. That is just pure water. And so you've got oil cutouts for the wrist pin on this versus no cutouts for oiling the wrist pin here. But that's also because the big difference between this and this is that it uses these snap rings versus this at a 2.5, the 2.5 liter using an actual, what they would call a press fit, where they actually heat the small end of this rod up and they push the pin in. And by doing that, it actually pretty much makes a fitment that is almost as good as welding. I really don't like saying that, you know, but it, you know, it's a lot of force that you're going to need to push that pin out. The downside of, you know, having a pressed in pin versus the floating pin, that's what this is the downside is you only have the wear surfaces around the piston that are actually able to move the rod, the wrist pin, versus you've got all this area here, you've got the area around the wrist pin on the rod. So if it's a little sticky, you know, in the morning, the motor doesn't have to always use these bearing surfaces to actuate the rod back and forth. Yes, you could very well, you know, find a machine shop that would bush the small end of the rod, but this is what happened in the 1980s. A lot of American manufacturers kind of decided to go with more of a press fit design because in many ways they thought that it was going to be faster than the snap rings, and in some ways it is, okay? But on a performance level, this is okay, garbage. I'm just going to say it flat out. So realistically, you've got a better performance piston in your diesel than you do your gasser. And another thing about gas pistons versus diesels is that usually gas pistons, from a production engine standpoint, I'm not talking some race motor, I'm talking actual, you've pulled grandma's car into the garage and you're about to do a reman on her motor for her, you'll find that these pistons will actually be sitting, you know, at TDC, what would be TDC, they still sit about 30 thousandths down in the bore. And that is also to control compression ratio. Okay. Versus the diesels. The diesels will either sit flush with the deck, or in the case of this motor, they actually do come out of the block 30 thousandths, because when you compress your head gasket down, they want this to practically be touching the cylinder head. They do leave you about 10 thousandths of an inch clearance, and you know, that's just for expansion. You know, metal expands and contracts. You really need to watch that when you're building an engine. That's why they have tolerances. That's why they have clearances. So pistons are actually a very widely debated subject, but you know, these are two factory-ish pistons, and realistically, folks, these are both from the same 1980s era. I remember this came out of a 85 Celebrity, and of course we all know that this came out of the 81 Rabbit Project. So post it down in the comments, you know, what you would like me to talk about in the next video. Maybe I'll make a part 2 on the Pistons series, on the Pistons, but yeah. Now let's talk about the actual giveaway. The giveaway, folks, you know, the giveaway was something that, you know, Super Clean sponsoring, and I came up with the rules, you know, and all you folks had to do, and you had to do all 3 things. You couldn't just do 1 or 2. You had to do all 3. Was you had to like the video. Okay? You had to just subscribe. And you had to put a comment down in the comments that was clean and non-offensive. You could have just said hi for all I care. Okay. Now, I'm actually going to pull up the comments so that I can have them on the screen. And you folks, now, there were only 2 comments. So, realistically, folks, there were only 2 people that entered for the sweepstakes. Next time, do all 3. When I say you gotta do all 3, you gotta do all 3. I'm not using a computer program to actually pick a winner. I am using the hat. Okay. Now, what I did is I took a template for mailing labels. So they're the 1 inch by 2 5/8 mailing labels, and I printed out 2 sheets, one with each person's name, and cut them up, put them in the hat. Okay, so now here's the winner. And the winner is Isaac Shaler. So, please PM me a good mailing address and we'll send your stuff as soon as possible. Now, his comment was, the winning comment: great videos, keep the content rolling. Now, folks, it was that easy. Next time that we do a giveaway, think a little bit, and you too could be a winner. So, thanks for watching. Isaac, PM me on the About tab. Email me your mailing address. I'll send that along to Super Clean, and they'll have your stuff out in the next 2 to 3 weeks. So, thanks for watching, folks. We'll see you on the next one.